Hopefully you guys are doing good today. It's a historical day being an inauguration. That's awesome. I don't care what party you are, it's part of history. And, for you guys, it only happens once in your high school career every 4 years. So, it really is something unique and different, and it's something that we should be a part of. So, all right, so today on the weekly schedule, there is the weekly notes right there in that link. I encourage you to go ahead and open those up. We're going to do the note today. So you see here, we're going to take some notes. We're going to do activity part A today. And then I'm going to put the session recording on there. That way kids that are absent can keep an eye on it, watch it. Tomorrow, you're going to be in person. Awesome, excited. I'm looking forward to seeing everybody. I kind of missed your faces. I don't even know if I recognize you very much anymore. It's been a while. But hopefully you'll be in class, wearing your mask, bringing all your materials. Tomorrow will be a pretty easy day. We're going to finish up our shirt and today's activity. If you're virtual, just be like this. Not a big deal. Log in, and you'll be pretty much seeing the same thing that you see right now. Just me in front of the room talking to the kids. I'll be wearing a mask, obviously, so that will cause a little bit of issues, but not the end of the world. Friday, we're going to take some more notes and do another activity. Note that there's no quiz this Friday. Okay. The quiz will be next Friday, and we'll talk about that in just a second.
Sorry, I was watching the inauguration.
Okay. All right. So today we are going to start Integrated Science B, Part B. I'm excited for this part. This is kind of the fun part for me. I really enjoy. I enjoy the physics and the energy part, but the space and the Earth and human impacts is really kind of the real stuff that we can be involved in, and some controversial stuff, and have some good conversation about things, especially what we're going to talk about today. So the rest of the year is going to be talking about space, Earth, and human impacts on Earth, and we're going to focus on space first for the next couple of weeks. And for this week and next week, we're going to talk about the actual formation of space, of the universe, and I'm going to talk about the Big Bang Theory. So this week and next week, covering that. So again, today we're going to cover slides 1 through 8, little activity, no quiz this Friday, we'll cover some more slides, another activity. And then next week, Monday and Wednesday, notes with an activity. And then next Friday, it's going to be a bigger quiz because it's going to cover 2 weeks of materials. Okay, so make sure you keep all these notes together. Make sure make sure you're studying them as well. Real quick before we go into others, note that if you make a copy of this notes right here, if you make a copy of what you're looking at, and you can, they're on your weekly schedule, note that it's not finalized. So if you make a copy, you're not going to get any more updates, okay? Because then it's yours. So next week, you're probably going to have to come and make another copy and get next week's lesson. Okay, so just be aware of that, that not everything is on here. Is ready to go. So today we're going to be talking about the Big Bang Theory. As normal, I encourage you to have pen and paper, take additional notes, make flashcards, whatever it is, during this lesson. If you have questions, write them down, put them in the chat box. Let's talk about it. Especially the Big Bang Theory. A lot of people have questions about it. So the very first thing I want to start off with is, what is a theory? Because this is really important for anything in science. When you start talking about theories, is that a lot of people have a misconception that a theory is not validated, a theory is not supported, or a theory is just an idea. And that's the furthest from the truth we can get when we talk about scientific theory. So follow along with me on the note. A theory, by definition, is well-formed, which means that it takes time, it's gone through the test and the rigors, and the scientists have debunked it or supported it. It was a well-formed idea. It's data supported. It has evidence. It has information. It has data. Okay. Colleague backed, meaning that other people support it, and a lot of other people support it. And it's an explanation of scientific phenomena. So well-formed, data supported, colleague backed explanation of science. Okay. That is what a scientific theory is. Okay. It is not just some guy sitting in the basement trying to figure out how the universe started. Okay, that might be how it started, but even after then, you got to get data, you got to go through your time, you got to put in the test, you got to get other people to support it. Okay, so while theory cannot be proven beyond a doubt, which is why it's a theory, Experiments and data can and must be collected to support a theory. You still have to have data. You still have to have experiments. You still have to collect information. Okay? Theories can also be used to make predictions about scientific outcome. So based on this theory, you think that this is going to happen tomorrow or next day. They can be used to make predictions. Now, again, most importantly, one of the things about theories is that they are supported by scientists. They're supported by people whose job it is to understand science. Okay? People whose job it is to talk about it, to debate about it, to write about it, to argue about science. The theories are supported by scientists. Maybe not all of them, but a majority of scientists. As far as scientists are concerned, scientific theories are the current explanation and facts of the universe. The scientists say this is what we believe has happened. We believe these are facts. Okay. Now again, they can be changed, they can be modified over time, which we'll talk about. The main reason why theory is not a scientific law is because it cannot be proven beyond a doubt. However, bright red, that does not mean the theory is wrong or incomplete or incorrect. Okay? Just because you cannot prove it does not mean that it is wrong. Okay? It could very well be 100% right. Okay? But we may never be able to prove it. And especially probably going to be the case with the Big Bang Theory. We're probably never going to prove it because we weren't there. We weren't collecting data. We weren't collecting information. Okay? Unless another universe is created and we can watch it and we can see it and we can collect data, we're probably never going to know exactly how the universe started. Okay? But that doesn't mean it's wrong at all. Okay? As new evidence and information is collected, scientists can modify theories, and that's what scientists do. That's what they're doing. They're trying to make the theory better and better and better. But then maybe someday the theory does turn into a law. Okay? Or they collect information and data and they can reject a theory. Okay? They say, well, this theory is no longer accurate because we have new information. So that's okay. Science is fluid. Science is flexible. Science is, is growing. It's changing every day. Okay? Especially with new technology. And that's your job. Your job is to go be a scientist and make changes and discover new things. Okay? You want to discredit a theory? You have to find evidence of a better theory. You can't just say, oh, that's wrong. Where's the evidence? Where's the data? What's the better solution? What's the better option? Okay. And so that is why scientific theory is very strong. And scientists essentially say that, that is what happened based on current information. Now, speaking of the Big Bang Theory, the reason why we're teaching it in high school and in Kentucky is because scientists say that this is the formation of the universe and this needs to be taught to schools. Okay. So scientists support this fact, and that's why we're teaching it to you. Okay, we're not teaching you all the crazy theories out there. We're teaching you ones that scientists support. Okay? All right, so what is the Big Bang Theory? Well, the Big Bang Theory is a popular TV show that ran on TV from 12 seasons from 2007 to 2019. Now, you've probably seen this TV show. That's not what we're learning about here, though. We're learning about the actual scientific theory. I can't play this video because it's going to block my recording, but you guys can play it on your own screen. Okay. All right. So that's not the Big Bang Theory we're talking about. This is the Big Bang Theory that we're talking about. So the Big Bang Theory is the current, well-supported, and evidence-based explanation of how the universe started. Okay. This is currently what scientists believe. So scientists began collecting data and working with the Big Bang Theory ever since about the 1920s, okay, especially with the advancement of telescopes. When telescopes been around for about 300 years, 400 years, but when the technology got better, scientists could look out in the universe and they can make observation, they can collect data, okay? But then they started asking questions like, hey, what's going on? Why is this happening? What's this? What's that? Okay? And so for almost 100 years, scientists have been working with the Big Bang Theory and editing it and modifying it and collecting data. So you would think that if the Big Bang Theory was not a good theory, that it would be gone by now, right? 100 years. But it's a pretty solid theory. This is still what scientists, based on data, it's still what scientists think happened. All right, so we got a French name here. This is a scientist, Georges Lemaitre, I don't know if I'm pronouncing that correctly or not, but he is a French scientist. Picture of him there. He's a Catholic priest, and I do put that information in there for a reason. He's a Catholic priest, and he's a professor of physics back in the 1920s. He is credited as kind of being the father of Big Bang Theory, kind of analyzing information, analyzing data, and he comes up with the idea that the universe is, or he comes up with the conclusion that the universe is expanding, and therefore, if you hit the rewind button, that if the universe is expanding, well, if I rewind it, maybe the universe came together and had a starting point. And so this is what we consider the Big Bang Theory, okay? So, in a sense, what happened, right? Or when did the Big Bang happen? The most important piece of evidence and data that we have for the Big Bang Theory right now is that the universe is expanding. And not only is the universe expanding, but it's accelerating in its expansion. It's going faster and faster and faster and faster. We talked about laws of motion. So objects in motion will stay in motion unless an outside force is acting on them, okay? So the universe is expanding and it's going to keep expanding forever until something stops it. Okay, we also talked about acceleration. In order to accelerate an object, we have to apply a force. Okay, so what is forcing the acceleration of the universe? What caused the universe to start moving? Well, this is what scientists were questioning. This is what scientists were trying to figure out. Okay, now scientists think it was the Big Bang. The Big Bang caused the expansion, but then we have to think about, well, why is it accelerating? So there are lots of questions that we still don't know the answer to, and that's okay. That's what scientists are there for. But measuring the rate of acceleration, and yes, we can do that, and we might even do that in class next week. If we can measure how fast the universe is expanding, we can hit the rewind button and figure out when the universe came back together. Okay, and it turns out the universe come back together about 13.77 billion years ago with a B on there. This number is constantly being modified. This is current number for it, but we can measure the rate of acceleration, and then just go backwards and figure out when did it start. And so the universe expansion started about 13.77 billion years ago. So, all right. So what happened? We're going to talk about timeline. Now, the moment of singularity, when everything was together, was called singularity, is a very unique and weird time. Scientists really still don't know exactly why things happened the way they did, but based on the evidence, based on the data, this is kind of what they think. So about 13.77 billion years ago, the universe was infinitely small. It was smaller than an atom. It was also infinitely hot. It was incredibly hot because all that energy was all concentrated in one particular little spot. Okay, so again, we're taking a whole universe that we have today, and we're going to compress it into the size of an atom, smaller than an atom, and that is going to get extremely hot. Now, it's not mass at this point. It is just energy, okay, because it's too hot. At that moment, for whatever reason, we don't know why, but at the moment of singularity, the universe began as a violent expansion. Not an explosion like a lot of people think. It's an expansion, okay? There was nothing before this expansion. People think that the universe was sitting somewhere in outer space and then pop, it happened. No, space is the universe. No, the universe, there's nothing there. There was no time, there was no space, there was no nothing. But then the universe expanded, and then that's where the universe came from. It came from that little atom, and it's growing outward still today. It's weird, okay? So all matter and all space were created from a single point of pure energy in an instant. That pure energy had a rapid inflation and expansion and temperature increase at that moment, okay? And again, it's pure energy at that point. It's not stuff, okay? So we think about an explosion, you think about stuff flying all over the place. That's not what this is. This is an energy expansion, okay? All right. About 3 minutes after the Big Bang, that little, nanoscopic universe is about the size of a grapefruit, about this big. Okay? At that point, it starts to rapidly cool down because it's expanding, it's increasing area. Think about a can of air compressor. When you compress air out of a can or you release the air, it comes out cold. And that's because the air is expanding, going from a can to, the room. If you release air in a tire, bike tire, car tire, feel the air. Air is going to be cold because it's going from a tire to the air. It's expanding. Okay? So when you have a rapid expansion, you're going to decrease the temperature. And then that is where the energy is able to be converted into mass or matter. Now, I know this is going to get kind of weird too, okay? But this is Einstein's famous equation, E equals mc squared. Energy can equal mass and matter. So when the universe went from being pure energy, hot environment, it cooled down and that energy converted into matter. Okay? And it starts to clump matter together, kind of like a snowflake will clump water together. And when it clumps that matter together, it formed the first proton, neutron, and electron. Now, proton, neutron, and electrons are made of smaller things that all got clumped together to make them what they are. So about 3 minutes after the Big Bang, we have proton, neutron, and electron. Okay? Those are going to be made to make atoms. However, it takes a really long time for that to happen. About 300,000 years after the Big Bang, whoa, we took a big jump. Okay, so we are expanding. 300,000 years later, okay, atoms are formed. Now, atoms are a collection of protons, neutrons, and electrons that are attracted to each other in F1. Now, the Big Bang primarily makes hydrogen. Hydrogen is one proton. Well, that's easy and simple to make. One proton with one electron. Okay. Remember, the protons do not want to be attracted to each other. They're going to repel each other. Okay, so making hydrogen is really simple because there's no repulsion. Making helium, however, is a little bit tougher. So there are two protons that don't want to be together. You need some extra neutrons to hold them together. Okay. It also made some isotopes of hydrogen. So if you look down there, there are 3 isotopes of hydrogen: hydrogen 1, hydrogen 2, hydrogen 3. They all have one proton. Okay, so that's hydrogen 1, one proton. Hydrogen 2 is one proton, one neutron. Hydrogen 3 is one proton, 2 neutrons. Okay, that's hydrogen 3. Helium is 2 protons, 2 neutrons, got a mass of 4. Okay. So the early universe was 75% hydrogen and 25% helium. Okay. And that ratio is still very similar today. And that makes sense because of the star formation. The stars make bigger elements. And how long have the stars been around? How many bigger elements can they make? We can actually calculate that. And our universe is still pretty much 75-25 hydrogen, helium. There are bigger elements today: lithium, carbon, oxygen, gold, iron, all those. Okay, but the percentage is incredibly small. And that's actually going to be one of our pieces of evidence for the Big Bang Theory. Again, if you guys have questions or anything, throw them in the chat box, okay? All right, so atoms were made about 200 to 400 million years after the Big Bang. The hydrogen and helium start coming together to form the first stars. Okay, so we're way after the Big Bang, 200 to 400 million years. Okay, so the first stars, all that hydrogen starts to accumulate, and it takes a long time to get all that hydrogen together. Okay, and they start to make the first stars. You put a bunch of stars together, you make the first galaxies. So galaxy there, galaxy there, galaxy everywhere. But again, even when they're making these galaxies, they are expanding. They're getting further and further away from each other. Okay, so all that hydrogen is still moving away, creating those stars and those galaxies. But then you go way into the future, about 9 billion years after the Big Bang with a B, our solar system is formed. And I just mentioned this because a lot of people think that our solar system was formed when the Big Bang happened. Nope. Long after the Big Bang. About 4.6 billion years ago, our solar system is formed when an older star exploded, called a supernova, and then gravity recollected that stardust and made a new star and new planets and comets and moons and asteroids and meteors and all that stuff. Okay, we'll talk more about that later, so we're going to talk about how Earth was formed. Our star is actually at least a third generation star. It is not one of the stars from the Big Bang or anything else like that. Okay, so 3 other stars have already been there, exploded, formed another star, exploded, formed another star to make our solar system. So our solar system is actually quite young compared to, the rest of the universe. All right. Now, some misconceptions that people have about the Big Bang. First, a lot of people think there was a massive explosion. No, it was an expansion. Okay. So instead of thinking about a balloon popping and spitting out all the universe, okay, think about a balloon having the universe, and the universe is expanding as you blow up the balloon. The balloon is not popped. Okay. I don't know. Maybe the universe is going to pop someday, but it hasn't happened. But the universe is expanding inside of a balloon. Okay. So again, it's kind of a weird concept. We also tend to think of the singularity as a little fireball sitting in outer space, and it blew up. There was no outer space. There was no nothing. There was no time. There was no matter. There was no space before the singularity. Okay, and so that's kind of a weird concept as well. Nothing was there. Everything was inside of that little singularity, and then started happening. Again, we don't know why it happened. The Big Bang made our solar system, planet Earth. Nope. That's not wrong. That's not right. Our solar system formed long after the Big Bang. Okay, and again, our star is at least a third generation star. Right, the Big Bang theory is the only current scientific theory about the formation of the universe. It's actually not. There are quite a few other theories, especially newer, younger theories, with the advancement of computers and supercomputers and modeling and things like that. There are other young, newer theories. However, most of the newer theories focus on the singularity moment. That's where the Big Bang has problems. Scientists don't know why the singularity happened. They don't know why the Big Bang happened. And so a lot of the new theories are focused on that part. But as far as the universe expanding, the data is out there. We pretty much know that. Sorry, I got something in my throat. So even the new theories that are out there, they don't really refute the Big Bang. They're just there to give ideas for why the Big Bang happened. Okay.
So could there be other universes?
What's that?
So could there be other universes?
I still didn't catch that. What was the question?
So could there be other universes that we just don't know about?
Well, that's a good question. Yeah, so that is one theory called the multiverse theory. It's also kind of the string theory. String theory and multiverse are very similar to each other, but maybe a different universe had a baby universe, and we're the baby universe. We don't know. Okay, maybe 2 universes touched each other and they interacted by making a new universe. We don't really know exactly what happened, but again, the evidence and the science and the data is really not there yet, and so that's the reason why I'm not teaching it to you, is because scientists don't really agree about the string theory or about the multiverse theory yet, especially the multiverse theory. We really don't have any evidence of that yet. It's a really cool idea, but again, why did the universe start is a really interesting question. And who knows? Maybe it is an old man sitting on clouds saying, make the universe. We don't know. We don't have evidence of that. So it's a really interesting question about why did that happen? Where did that energy come from? We don't know. The last misconception is that it's just a theory. That's a very poorly stated statement, especially when you're talking about scientific theory. That's not a very good argument. Just because we can't prove it right doesn't mean it's wrong. And again, when you have a bunch of scientists saying, yeah, this is what we think, it's really hard to argue against that. These are people who make their money doing science, and so that's what scientists agree upon, like, hey, we want kids in high school to learn this, and this is why, because there's a lot of data behind it, which we're going to talk about in the next couple of days. All right, there are some additional resources I highly encourage, especially if you're interested in learning more about the Big Bang Theory. If you're interested about other theories, I would type in other theories and see what other things pop up. Again, make sure they are science related. really don't want conspiracy theories with no data and no information. I totally understand that there's probably lots of religious ideas as well. I respect that. I understand it. Just make sure that there's evidence and there's data and there's information uh, in order to form your own education, in order to form your own opinion about what happened here. Lots of cool articles and videos, especially NASA and stuff. Um, NASA does a really good job kind of talking about what happened as well, and they actually kind of show some pictures about what they see as well. All right, today we're going to do an article, a little activity. I'm going to put you guys in a group for about 10 minutes. Today's activity is going to be an article about the difference between a theory and a law. Then I'm going to ask you to watch a video and kind of summarize the timeline of the Big Bang Theory. I didn't give you every piece of information. I kind of gave you the big ideas. But the video kind of goes into more detail about when things happen, how things happen, why things happen. But it's a short video, I think like 4 or 5 minutes. The article you're going to read and answer 3 questions. It's a blog, but it's by the Science Journal. I really like the guy's take and interpretation on theory versus law. And he's also very honest about why people argue certain things when they talk about law versus theory. The article today is not about the Big Bang Theory. It's about all theories. Okay, it's about all laws on it. All right, so you guys are going to work together, help each other out, read the article, ask each other questions. When you guys go into the chat box, if you guys want to argue stuff and talk about like why Mr. Can's crazy and wrong, go ahead. Just make sure that we're respectful about everybody's opinion. Okay, myself included. I'm not saying that everybody else is wrong. We don't know. We don't have the evidence. Okay. So just be respectful in your discussion, especially when things are really a hot topic or controversial. To be honest with you, though, the Big Bang Theory is not really all that controversial anymore. It's been around for about 100 years. This is pretty much what people think. Okay, if you're still arguing about something after 100 years, probably lost that argument by now, right? All right, so let's get into groups and let's work on our assignment for today. If you guys have questions, feel free to ask them. I'm going to stop recording because it doesn't record your breakout groups. So I'm going to stop that.